Hi everyone, today we're going to be filling and labeling gait trials. First, make sure to open up Qualysis and click on No Project. Once you are in Qualysis, go to File in the top left. Click on the trial you would like to post-process. Make sure your file is labeled in a clear and consistent way so it's easy to find later. When I first load a trial, I like to minimize the trajectory editor and message box. This gives me a better overall view of the trial. You can move the camera by holding a right click. You can zoom in and out using the scroll wheel. On the right side, you may notice some floating red markers. This indicates that Qualysis is visualizing markers. As we play through the trial, more markers will appear. Now we can clearly see the participant's gait pattern. Pause at the point where you want the participant to start. Use the arrow at the bottom left, as you can see, to trim the start of the trial. Make sure the participant properly makes contact on the force plate that you want to analyze. Next, find where you want the trial to end. I usually trim the trial to the point where we no longer see force vectors, typically just after the last force plate. Now we're ready to label. Go to the label trajectories, which is the black box in the top right. Right click and select Load Label List. Make sure you have downloaded the dynamic label list that was provided. This dynamic label list contains fewer markers in the static trial. I like to move the participant to a frame where their legs are straight and the markers are easy to identify. From there, find a camera view that makes labeling easier. Click ID on the vertical hotbar to your left and begin labeling your participant. Over time, as you continue labeling, you'll become more efficient, not only at labeling markers, but also at understanding proper marker placement and anatomical landmarks. We'll also cover different filling situations so you can continue to improve your overall efficiency and accuracy. I recommend that you pause whenever you feel like you need to, or continue as you feel comfortable. For our marker set, we use a forward C shape for the thigh and shank clusters. It's also important to note that the lateral thigh and shank markers face the posterior side, while the medial thigh and shank markers face anteriorly. You can also use the trajectory editor to examine each marker's movement across all three planes. In a good gait trial, you should not see any red flags such as sharp jumps or jagged or spiked trajectories. As long as the markers are securely placed, this will usually not be an issue. For final checks, always make sure with any of your trials, make sure every marker is filled to 100% whenever possible, and also double check or even triple check for marker swaps, misplacements, or excessive movement. Always use what makes logical human sense when reviewing your data. Now we have finished labeling, and for the next part, I will show you how to export this .c3d file. To export your trial, hover over File in the top left menu, move your cursor to Export, and select to C3D. The C3D export settings window will appear. For our purposes, no changes to the default settings are needed. Simply click OK in the bottom left corner of the window. When saving your file, use a clear and consistent naming convention that aligns with your gait trial, including the participant ID, trial number, and task. Will make files easier to sort and retrieve later. In the next video, we will cover how to use your .c3d files to analyze and interpret gait data in Visual 3D. Here I pulled the trial up where there are gaps in some of the marker trajectories, meaning we do not have 100% marker visibility throughout the trial. When we click on an individual marker, for example, LMTH1, that is only 96.8% filled, the trajectory editor will display an orange box indicating a gap in the marker trajectory. The trajectory editor is a key tool for filling. It allows you to visualize gaps, identify natural spikes, and observe marker movement across all three planes. As you scroll through the trial to the gap, you'll notice that the marker disappears from the labeled model. To fill the gap, click and drag across the trajectory lines on either side of the gap. Then select the Paint Bucket Fill icon or press Shift plus F at the same time to apply a polynomial fill. As you scroll through the video, you can now see the marker reappears. And in the trajectory editor, LMTH1 is now 100% filled. And that's exactly what we want. Now let's work with the cluster marker, such as the left thigh marker LTMTH. which shows 86.7% fill. You'll notice two gaps where the marker is not visible in certain frames as we scroll through the trial and the trajectory editor. Cluster markers belong to cluster plates, which are groups of markers that define a body segment, such as the thigh, shank, or foot. When cluster markers have gaps, it is typically best to use relational fill. You can find this option in the top right corner of the trajectory editor. Select relational from the fill type menu. In practice, you will mainly use polynomial and relational fills, so there's no need to focus on the other options. When using relational fill, select 2 to 3 markers from the same cluster plate to define the origin, x-axis, and xy plane. Typically, you'll only use 2 for the heel, but for shank and thigh, you will use 3 markers that are part of that plate. It doesn't matter which marker you select for those boxes, though, as long as they belong in the same cluster plate. When selected, fill the gap using the paint bucket tool. Be sure to review the trajectories carefully and watch for abnormal movement in the trajectory editor. And now we're going to do the second gap, as you can see. So feel free to pause, rewind if you need to, or skip forward. But I'm just going to show you guys again as another example. Finally, one more example, we will fill the RASIS marker using a polynomial fill to demonstrate how easily you can switch between relational and polynomial methods. Here I'll demonstrate an example of an incorrect relational fill using the marker RTLTH, which is our right top lateral thigh, where we will have a marker from a different cluster plate accidentally selected in our filling. In this case, we mistakenly include the RBLSH, which is our right bottom lateral shank marker during the fill. Visually, the RTLTH marker appears only slightly altered because the gap is small. However, in the trajectory editor, you can see that the coordinate axis behaves abnormally. This type of error can lead to issues later in Visual 3D, including incorrect kinematics or inaccurate calculated metrics. Now that we're finished, make sure to double check all markers to confirm they look visually correct, with no excessive stretching or unrealistic movement, and that all fills are 100% complete. This concludes a brief overview of common filling problem-solving steps.